The learning objectives for this lecture is that you will understand average atomic masses and what they represent, as well as be able to calculate average atomic mass for individual specific elements. Okay, so the average atomic mass is the number that you actually see on your periodic tables below your element symbols. So remember, this number here is not your mass number. Mass number is the number of protons and neutrons and is not found on the periodic table. The number that you see below is actually the average atomic mass. And now, average atomic mass is actually a weighted average of the atomic masses of all the isotopes that occur naturally for that specific element. So a major difference to help you differentiate between the average atomic mass and your mass number is that your mass number is always going to be a whole number because it's your accounting number, while this number is usually going to have some decimal places because it's an average. So in order for us to understand what a weighted average is, let's go ahead and let's look at this imaginary sample here. Okay, so I have 10 total atoms in this sample, and notice I have two different color atom types. I have these blue ones and I have the black ones, okay, and the different colors represent different isotopes. Okay, so if we were to look at the total number of the blue isotopes, we would count up a total of 7 atoms. Okay, so in this particular case, 7 out of 10 of the atoms are going to correspond to the blue isotope. On the other hand, 3 out of 10 of the atoms are going to correspond to the black isotope. Okay, so if we multiply this by 100, multiply this by 100, this is going to give us 70% of the atoms corresponding to the blue isotope and 30% corresponding to the black isotope. Okay, and if the blue isotope and the black isotope are what are making up the average atomic mass, 70% of that mass is going to be coming from the blue isotope, and 30% of that number for the average atomic mass is going to be coming from the black isotope. Okay, so basically this is what average atomic mass is, and now we're going to go ahead and look at how to actually calculate this for real examples. In order to calculate average atomic mass, you need two pieces of information. The percentage abundance of each of the isotopes that make up that particular element, and of course the atomic masses of each of these isotopes. Now again, notice that the isotope masses are different from one another, which would be expected. So copper-63, the isotope copper-63, has 2 less neutrons than copper-65. And so we would expect copper-63 to have a lower mass than copper-64. Okay, now, in order to do this, what you're going to do is you're going to first take your percentage abundances and put them into decimal form. So in order to do that, you divide these by 100. Okay. Then you're going to take those decimal values and multiply them by their corresponding atomic mass of each of the isotopes. Once you get the product of that multiplication, then you're going to add those two numbers together to get your average atomic mass, which is the number that you see below the element symbol on the periodic table. Okay, so let's go ahead and practice this. So in this particular example, guys, we have 3 different isotopes that make up our specific element. So if we go ahead and follow our steps, the first thing we're going to do is we are going to divide each of our percent abundances by 100. Okay, so now that we have divided each of our percentages and put them into decimal form, we're now going to take these decimal values and multiply by the corresponding masses associated with the isotope. So isotope 24, we're going to use this number, isotope 25, and 26, and on. So let's go ahead and do that multiplication. Okay, so now that we've multiplied our masses of the individual isotopes by the decimal forms, we're going to go ahead and take our answers and sum them all together. Okay, and so the summation of all of these is going to equal 24.305 or 24.31 AMUs. Okay, now they want us to identify the identity of the following element. So what we're going to do is we're going to go to our periodic tables and look at the average atomic masses. And if we look at the average atomic masses, if we get to magnesium, we go ahead and see that magnesium has this average atomic mass. Okay, so this is how you calculate them. Make sure if you follow the steps, you'll be good to go.